We are back with yet another video in our display series, continuing our deep dive into UI development. In the last video, we explored LVGL core functions and broke down some crucial points step by step. This time, we will shift focus to the UI files generated by SquareLine Studio. We will walk through the structure of these files, highlight the small tweaks you need to make, and show how they connect back to the LVGL codebase we set up earlier. And of course, this is all in preparation for our upcoming end of the series hands-on practical demo where everything will come together on the hardware. Namaste and welcome back to Avinashee Tech. Here we break down the world of embedded technology from understanding controller internals and hardware schematics to writing clean, efficient code for real-world applications. If embedded tech excites you, then hey, you are at the right place. We already covered the basics of using SquareLine Studio and creating a simple UI in one of our earlier videos. If you haven't watched that yet, go check it out. The link will be available in the top right corner. Now, with the UI code generated, let's open the project folder in VS Code. First, let's open UI.h. Make sure the correct path to lvgl.h is set. This ensures the compiler can link our UI code with the LVGL core library. Next, in UI.c, there's a small but important change, that is, update the LV color depth from RGB332 color format to 1 byte per pixel monochrome. That means set the value to 1. What we are basically telling LVGL is, hey, if the color depth isn't set to what we had set in the LVGL config file earlier, just throw an error. Since our SST1306 is a monochrome display, this makes sense. Now, looking inside UI.c, you will notice two key functions, UI init, UI destroy. Inside UI init, we first obtain the default display object. By default, LVGL sets a theme here, but we will remove that and instead apply the mono theme, which is suited for monochrome displays. Once the theme is set, we call the UI screen1 screen init function. Now let's open UI screen1.c. At the top, you will see a bunch of LV OBJ pointers declared for our widgets. These include one screen, a couple of panels, and a couple of text labels. Just what we created in one of our previous videos based on SquareLine Studio introduction. Scrolling down to the init function for UI screen 1, I will be removing the line that creates a new screen object. Instead, we will use LV disp get scract, which directly returns a pointer to the already active screen created when we registered our display. This way we avoid creating redundant screen objects. After this edit, here's how the structure looks. UI panel 1 has parent screen 1 with attributes like size, coordinates, and border style. Label 1 has parent panel 1 with attributes such as size, coordinates, text HH representing hours, and lastly style. Similarly, panel 2, panel 3, and panel 4 all have screen 1 as their parent. Label 2, label 3, and label 4 each sit inside their respective panels with label 2 text set as MM representing minutes, label 3 text set as SS representing seconds, and label 4 is set to a date and day, which is something we won't be changing. In the end, after adding all the child widgets, we load UI screen 1 as active screen. As for the screen restore function, it's pretty straightforward. It simply handles cleanup of the widgets that was created for this screen. Alright, now that we have our UI source files, it's time to connect them with the LVGL code base we built earlier. Let's head back to the GUI task we discussed in the last video. Remember here, we had LV init, partial buffer allocated for display data, draw buffer initialized, and display driver structure members being set up. Previously, right after this, we jumped straight into adding text and images. But this time, we will remove that and instead call the UI init function from our UI.c file. Once UI init is called, we will create a timer with a 1 second period using the LV timer create API. The callback function update clock will run every second. The logic in update clock is also straightforward. After every 60 seconds, increment minute, reset the seconds. After every 60 minutes, increment the hour, reset the minutes, and after every 24 hours, reset the hour count. Inside the while loop, we will maintain a small static character buffer. First, we will place the current hour value in the buffer, then use LV label set text to update label 1. Next, we will reset the buffer, copy the minute value, and update label 2. Finally, we will repeat the process for the seconds value and update label 3. And of course, as before, LV task handler keeps everything running smoothly in the background. So that's it. The code side of UI development has been explained. With this, we are now fully ready to bring all of this knowledge that we have accumulated onto our real hardware, whether it's the ESP32 or the STM32 in our upcoming videos. And that's where I'll hit the brakes for this video. The LVGL library together with the SquareLine Studio is huge and packed up with tons of features, way more than we could cover in a single video. So I encourage you to experiment, tweak things, and see what works best for your project. Be prepared for the next video where we will get hands-on with actual microcontrollers. Till then, don't forget to like, share, and subscribe to the channel for more content like this. This is Avinashee Tech signing off. Keep learning and see you in the next video.